Hello again, Year 6. It is day 3 of your maths this week, and I'm here again in my snug, making a video for you. This is my last video of the week because tomorrow is some shape work, and again, we've printed some stuff off. We've also printed some stuff off today. We dropped off quite a lot of paper early on this week, and so you shouldn't need me tomorrow. Okay, you'll need to read through the learning reminders carefully and remember what reflection, rotation, and translation mean. I'm not going to remind you, and then you can get on with the work tomorrow. But today, we've got one final exciting investigation, as I'm calling them. And again, as ever, I am joined this week by my maths dog, Ziggy. He is fast asleep next to me. Should I see if I can... Ziggy, come say hello. Come say hello to the girls and boys. Look, look, look. Tell them, say Ziggy, maths is good. Maths is... No, nothing. No? Okay. That was Ziggy's opinion of maths. Hopefully, yours is a little bit more excitable. Nothing more, Ziggy? He's got nothing more to say. So I'm going to show you a presentation today because we have the pièce de la résistance of exciting maths. We are looking at sequences and we are looking at a very specific sequence today. Let's have a look at that sequence. Oh, he says with excitement in his heart, here it is. 1, 1, 2, 3, 5, 8, 13. What's going on? Girls and boys, this is a very famous sequence. Do you recognize it? Do you think you know what's going on? It is called, oh, that's my alarm clock, just to let you know. Well, it's not my alarm clock, it's my cuckoo clock, which isn't a cuckoo, it's a monkey. Moving back to the maths, it's lovely being at home. This is the Fibonacci sequence, girls and boys, and again, it's one that we have talked about before. It is beautiful and glorious and wonderful. And it is named after a 12th century mathematician, quite hard to say, who wrote about it. Now, the question is, do you remember how it works, or can you see what is happening with this sequence? 1, 1, 2, so 1 and 1 and 2, 1, 2, 3, 2, 3, 5. I'm giving you big clues. Can you see? What you do with this sequence is you add the last two numbers to make the next number. So 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, 3 add 5 is 8, 5 add 8 is 13. Now, have a go then. What are the next 3 terms? Go. We've done this before. It's getting very dark in here now. The clouds are rolling in outside. Go. All right, let's have a look. Hopefully you got 12 and 1, 34, and 55. So this sequence could go on forever. Now, you're all thinking, the question everyone asks is, well, what about the start? Well, we start with 1. What we're going to do, nothing before 1, so we can't add anything to it, so then it's 1. That's how the sequence begins. And then from then on, it is just going up. And it will get bigger and bigger and bigger. And it is so interesting. If you have any time at the end of the lesson today, do some research about the fantastic little fun tests you can do on the Fibonacci sequence. So, moving on quickly, I can tell you but the total of these numbers is 143. This is one of the tests. How do I know that so fast? Partly because the PowerPoint presentation said it, but also because what we know is you can find the total of any 10 consecutive numbers by multiplying the 7th number by 11. That's insane. That's crazy, girls and boys. Why does it work? Okay. Does it work with 10 numbers? Does it work with these 10 numbers from the sequence? What's the 7th number? 1, 2, 3, 4, 5, 6, 7, 13 times 11? Obviously, 143. Do all of these numbers add up to 143? Can you do it? It'd take a while, but it does add up to 143. It works with any 10 numbers on a sequence. How about these ones? Okay, can we find the 7th number? 1, 2, 3, 4, 5, 6, 7. Times it by 11. That's pretty big, isn't it? Should we get the presentation to do it for us? We're going to get a calculator out. You could do all of this today. You can have some great fun. It's 605, and they do all add up to 605. Hold the phone. That doesn't make sense, but it is maths, girls and boys, and it is beautiful in its complexity. So you're going to have a look at this sequence today, and you're going to also be having a look at this glorious triangle. This is called Blaise Pascal's triangle. It's called Pascal's triangle. Okay, and he also, this relates nicely to Fibonacci's sequence. So here comes Pascal's triangle. He puts a 1, and then 2 more ones, because 1 add to 1 is just 1. And then here he goes. Can you see what's going on? We're going to keep it rolling out now. Here it comes. Can you see what's happening in Pascal's triangle? What would you write in the next row? What do you think? What would be here? It would still be a 1. Can you see that it's nicely symmetrical? How about here? Anyone got any ideas? Hopefully you started to think it might be 6. Let's have a look. All right, do you see the pattern? It's a great triangle. And on and on and on it goes. And it goes on forever. And you might be looking now thinking, hold it. I can start to see all sorts of interesting patterns, all sorts of interesting things about it. Okay, and you're going to be investigating today. And again, we've printed off a triangle for you so that you can do that. All right. So what are the patterns we can see? Can you see any? There are a lot of great patterns. Let's have a look at them. All right, here we go. Here's a few. All right. Ah, look. What do you see about these numbers? This is interesting. All right, lots of interesting things going on in this. Okay, they're triangle numbers. All right, do you see them? And they go on and on and on and on and on. Brilliant. All right. If we add them, 1 and 3, we get 4, which is what? 3 and 6 is 9. 6 and 10 is 16. 10 and 15 is 25. 15 and 21 is 36. You should recognize that sequence of numbers. It's square numbers, girls and boys. All right. And amazing. Look at that. It's just incredible. Okay. What about if we add the numbers that pass through the line? 1, 2, 3. Can you do it? On and on and on and on and on. You should start to recognize 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. Hold the phone. It's a sequence we know. It's Fibonacci. Okay, so you can see Blaise Pascal's triangle is amazing. And you're going to play around with it today. All right, you are going to have a go at doing that. I don't know, I got my screen off there. That was a bit of a pickle, wasn't it? So you should have a look at your learning reminders again. It shows you a few things, but also you should have Pascal's triangle to look at. And there's a task there for you to have a go at and play around with Pascal's triangle. There's also a few other investigations of Fibonacci's sequence and different things to have a go at today. You can do all of them. You can pick the one that interests you most first. It is up to you what you do today, girls and boys, but I hope you do some great maths. I say go. Ziggy also. Say go, Ziggy. Tell him. That's right. Oh, do good maths. I've lost my mind, girls and boys, but I'm thinking it should go really well today. So do some good maths, and I will see you soon.